My name is Ahmet Eren Üçel and I will introduce my term project for Physics 102, General Physics 2. As in this setup, we will examine the impact of angle of insertion of this magnet through a magnetic field which is created by this loops of wires, and we will examine the impact of this angle of insertion on the EMF induced through using this multimeter. Let me first talk about the setup. I use these two standing blocks to make this setup more steady rather than using a human-based setup. We will have some crocodile clips that connects the tips of the multimeter to the two tips of this magnetic field. And as you can see, I tried my best to level these two in the same level, at the same height, so that there occurs no error beforehand. And I will try to change the angle of insertion of this magnet through the copper coil, and we will examine this situation's impact on the EMF induced. For example, by far we will also the concept that we examine is Faraday's law. Faraday's law suggests that this EMF induced is related with the N loops, the amount of loops of this copper coil, and the magnetic flux induced. And the magnetic flux can be found by the strength of this magnetic field and the area that we use, but we also depend on the angle that we use, and this angle is about the sine of theta. So in this case, when we have 90 degrees of insertion, we expect to have the greatest induced EMF because sine of 90 is going to be 1. However, when we do this in the horizontal case, we will have sine of 0, so we expect that to be, we expect 0 EMF to be induced. I will try to change this angle by 15 degrees at each case. For example, right now it is 90, and we will just change this setup by like this to change the angle of insertion by 15 degrees up to 90, and we will examine the impact of this rotation angle on the EMF induced through the readings on the multimeter.